we're asked to say which function could be the derivative of this function. I'll have to take a look at the options, but we can at least get an idea from looking at the graph. Sorry, computer's going slow here. Okay, that'll have to do. So, the function is increasing. It's positive at x equals -2. It's still positive at x equals -1.5, somewhere between -2 and -1. And then it looks to be 0 at x equals -1. And then the graph, the slope, the instantaneous rate of change of the function is negative between -1 and 0. And it's still negative once we hit 0. So these are important signs to keep in mind. The graph, the derivative, needs to be on the positive side of the y-axis, because now the y-axis isn't y values, it's little instantaneous rates of change. So at -2, it should be a pretty steep positive number. At -1.5, somewhere between -2 and -1, it should still be positive, it's just not quite as steep. So if this is -1, then this value has started to level off compared to this one. This one's really steep, this one is less steep. So -1.5, we should be getting closer to 0. Then at -1, we should have 0 at the derivative, because the slope at -1 is 0. And then between -1 and 0, we have a negative slope, so we should have a dot down here, somewhere on the negative side. At x equals 0, we should still have a negative slope, so we're negative on the y-axis. Still negative, still negative. And as we get closer to x equals 1, the slopes are getting closer and closer to 0. This is pretty steep, this instantaneous rate of change. This is a little less steep, and this is less steep. So those dots, as we get closer to x equals 1, they should still be on the negative side of the y-axis, but just closer to 0. And then once we finally hit x equals 1, we have a slope of 0. And now if you draw a tangent line, the slopes are positive, right? So we should have positive values. So it should look something like that. So that looks kind of like what we have. That one might be a winner. That one's definitely not it. That one's not it. That one's not it. So the only one that could potentially look like it, the graph that we just drew, is this one right here.